My name is Axel. I come from the town of Añasco, Puerto Rico, and I'm an inventor. A year ago, I was given the challenge of competing at the school science fair. I decided to look for a potential problem that could be solved using STEM: science, technology, engineering, and math. Right about the time, I read that more than 36 million people in the world are blind. I decided to develop a project that could maybe help the blind population have a better lifestyle in some way. What I came up with offered a new breath of life to them. The idea is a pair of glasses with ultrasonic sensor components integrated to them. They give the user a slight warning whenever they get close to obstacles near their upper body. Waves go from the sensors toward the obstacle and they bounce back, and using a program from the microcontroller, it calculates the time that those waves took from the glasses to the obstacle and back, and it calculates the distance. For the second phase of my project, I decided to include artificial intelligence. I decided to upgrade to the more powerful Raspberry Pi Zero-W, which also included Wi-Fi and Bluetooth connectivity. On the top, there are two ultrasonic sensors in a 3D printed support I designed. In the front, there's a micro camera used to identify and classify objects using AI. The device's program is written in C++. For the artificial intelligence, I used the Cloud Vision API from Google Cloud Platform. It allowed me to rapidly add services such as label and face detection. First, the program takes an image using the micro camera. It converts the image to base64, a text-based encoding format. The program then generates a JSON request, which contains the necessary information for the API to process the image. It uses curl to send the request to the API, containing necessary parameters such as the API service endpoint and the key. Once the API receives the image, it goes through an artificial intelligence process. First, the image is segmented into smaller groups of pixels, called filters. These pixels are processed, searching for certain patterns such as edges and curves. The patterns are then compared to massive datasets called convolutional neural networks. These contain millions of pre-labeled images which are used to identify certain features of an image by comparing them to the rest of the network. Finally, certain objects are identified based on these features. The Cloud Vision API sends back a JSON response containing the classification labels as well as the percent of certainty. The program identifies the closest prediction and uses the Pico text-to-speech engine to notify the user.
There is a guitar in front.
Obstacle is 44.7 inches away. Obstacle is 37.2 inches away. Obstacle is 21.0 inches away.
We went through many iterations of the prototype, making certain improvements between each one of them. In the future, I hope this can help a lot of people. It shows how innovation can change our lives.